All right, let's go ahead and get this fired off. So welcome to the Rise Up podcast. My name is David Schultz. I am a principal consultant and solution architect for Rhize Manufacturing Data Hub. And here today, we're going to talk about all things manufacturing, but specifically, we're going to get into the ISA-95 standard. There's been a lot of conversations around that, and my position is that it is not very well understood. And that leads to a lot of confusions. And confusion in its application, and can we use it? Is it still relevant? And I am joined today by Rhize, who is an ISA-95 expert, guru, whatever word you want to throw in there. For the purposes of today's discussion, we're going to keep it very high level, and in future episodes, then we'll certainly start getting more into the weeds. But with that, Rhize, could you take a few minutes to introduce yourself and tell everybody, or tell the audience who you are?
Yes. Hi. Thanks, David. Nice to meet you all. My name is Rhize. I'm working now in manufacturing IT for about 17 years. Always mainly focused on MES and MOM domain. I think we will come back on those abbreviations later. I implemented a lot of MES solutions for various industries, also very large multi-site MES projects. I did it in the roles of a software engineer, a team lead, consultant, different phases. Almost all of these projects were always with the ISA-95 standard as a guiding principle. So yeah, a lot of experience in that.
Right.
Now I'm working for Rhize as an MES, MOM consultant, and mainly focus on getting workshops to gather requirements, map the source data to the Rhize ISA-95 model.
All right, excellent. Well, welcome. Glad you're here. Looking forward to really understanding more about the ISA-95 standard. But I would be remiss when we start talking about standards if we couldn't get to an XKCD cartoon. He seems to have a cartoon for just about everything IT related. So here's the current situation. There are 14 competing standards, and you get two people together that say that's ridiculous. We should develop one universal standard for it, and soon, eventually, there are now 15 competing standards. And I think you can take a look at a lot of the standards out there and say, yep, that's pretty much the case. So, with that, let's get into ISA-95. And can you provide a little background of, what is the ISA-95 standard and why was it created? Why was it developed? What was the intent?
Yeah, the ISA-95 standard is really focused on manufacturing IT, so on businesses systems on level 4, but all down to the factory systems and control level.
Okay. Just real fast, let's make sure we're defining terms. So you said level 4. What do you mean by level 4?
Yeah, that's more the business systems. So that can be systems like an ERP system, a CRM system, the systems that are really like, the business systems. So things like financial systems outside the factory.
Yeah, and I assume that since there's level 4, there's probably a level 3, a 2, and a 1. Can you provide just a quick overview of what those are?
Yeah, so level, I can show you also a picture.
Oh, perfect.
So this is, for example, an overview of the different levels. Like I said, level 4, for example, it's ERP, but there are multiple systems that are in that level.
Okay.
Level 3 is MOMS, again, an abbreviation. It's the Manufacturing Operations Management System. And that is, for example, an MES system, so an execution system, but it can also be a maintenance management system or a warehouse management system. All kind of different solutions, but it's really focused on the factory and it's above the process and control level, and that's more than the level 2, the level 1. So level 2, you can think about a SCADA application where you monitor your factory, where you can control the automated processes. And then the PLC is really executing, so it's really the programmable logical controller. So it does all the steps in the automation. So it's connected to sensors, connected to agitators, to all kind of devices, and it's reading and writing at the right moment the logic. So it's also on the completely right. You see, it's also a different time span. The PLC is really milliseconds or seconds. If you go up to SCADA, it's more like minutes, maybe hours. The MES and the MOMs, that's more like, okay, it's shifts or hours or minutes, could be days. And then the business system is also a bit higher up.
Okay, perfect. So if I understand what you're saying, the whole intent of ISA 95 was to help us understand how we integrate these various systems. And as I've looked at it, looked at the standard itself, I think there's currently 8 parts, soon to be 9. Can we just talk a little bit about, maybe at least the first 4? I think those seem to be the ones that are most relevant, or at least certainly for the purposes of our conversation. So can you provide a little insight of what's there and why people should take a look at it?
Yeah, and to come back a bit on that ISA-95, let's discuss about the whole interaction, the exchange of information between the different systems. So started with that level 4 and that level 3. Part 1 is really a general introduction. It's a lot about terminology, about the language, about the scope. So I think it would be good to have that part 1 as an introduction. Then the part 3, let's skip to 3, that's more on functional level. So it's really about, okay, what are the activities in your company and how can we make a general model on that based on the different domains. So you have, for example, production, maintenance, inventory and quality. And there are all kind of activities in those 4 domains. Then the part 2 and the part 4, that's more about the real data model. So the objects used for exchange as well. Part 2 is really focused on the level 4 exchangement to level 3 and backwards. So between level 4 and level 3. And part 4 is more focused on between level 3 systems and also between level 3, level 2.
Yeah, I think amongst all 8, soon to be 9 parts, there's well over 1,000 pages that are in there. For the average bear, it almost seems like, well, this is really ominous. I can understand why people may not use it. So, how are people actually using it currently? What have you seen in practice using the standard?
Yeah, it's used in very different ways. Actually, it's at a certain moment there were more and more MES solutions that were really focusing on S95, especially on the way to connect to an ERP system. And then they got solutions that said we are like compatible with S95, so they were using the same terminology, trying to use the same data model, but that's pretty hard. It's very normalized. And now you see it that it's also used in documentation, for example. So when you write your user requirement specification, it's already used in the S95. And then also when you do your functional design, it will be used all through the documentation and then also through development.
Okay.
So you see it used more and more. A lot of people, also customers, more and more customers are also understanding it already. They had courses or so sometimes, we meet customers with different level of expertise. But it's mainly used to get the same terminology and to get in the same way of for with a supplier and the customer, for example, that you talk in the same language.
All right, perfect. So it's really just getting everybody on the same page to make sure we're using the words correctly and we're passing the information back and forth in a way that we've all agreed of, yes, this is how all this information will be exchanged. So, and I've heard, recently that, the ISA 95 standard, it's old, it's antiquated, that it really doesn't apply. Just curious your thoughts, comments on that.
Yeah, in my opinion, it's very valuable because yes, I'm talking about documentation, about a language, but also to store the data model. It's always a challenge that you get a solution, you get requirements for a certain project, and it's never fitting. So because a solution is built without any flexibility, but you always need more. Mm-hmm. And that's where I think the S95 is really good at. It's very flexible. It's also pretty abstract sometimes, but it helps in really setting like a sort of a starting point, but then it's expandable. So you have, for example, as many properties as you want and as many types as you want. So you can really extend that whole model into a very, yeah, it's a very flexible way of storing data and of designing your applications.
Okay.
So yeah, for me, it really helps in design.
Sure. So, again, going back to the robustness and it's certainly not a small standard relative to some others. I mean, is this more appropriate for large or small organizations, or, is there really a guideline as far as that goes?
I don't think there's a real guideline on it. I would say it's mostly a bit bigger companies, but that's more because they took the investment to get their people aligned and educated on it.
Okay, so smaller organizations can certainly use it. It's just what we have seen is it's the larger ones that have, only because they're potentially using systems that might utilize the standards. That a fair way to
Yeah.
characterize that? Okay, perfect. So in just terms of, again, going back to the application, is it something where if you're going to apply the standard, is it an all or none where you either have to use all of it, or can you use, bits and parts? And if you're going to use bits and parts, what do you think are the most critical bits and parts to use out of that?
Yeah, it's a bit dependent on also the solution, but looking at the data hub at Rhize, we really did use cases specific. So just starting with, for example, receiving orders, getting some master data in, and then you get your actual production done. So your consumptions, your production, starting with that. That's often where we're starting. And then you add more and more functionality. So yeah, it's really per use case you could start using it. You have to think about the bigger picture. That's always the difficulty. You can start by use case, but at the beginning you have to start about the whole company wide. Like, okay, how should I do this? And then you can start with a smaller piece.
Sure. Yeah, I mean, that seems very similar to, there's been conversations as far as manufacturing systems in general go, is should we start with the back end or should we start with the front end? And what I mean by that is, should we start with how people are going to use it, or should we start with getting the data, the back end ready to go so that it has a lot more flexibility on the front end? Of course, I'm in the latter camp of we start with the back end and then do the front end. It seems in this case, we're kind of doing a little bit of both of, yes, there is the standard, but let's work on the use case and then apply that use case to the standard. Is that fair?
Yeah, for me, it's really important to start with the back end because the front end, I saw solutions where they also put the whole ISA-95 terminology in the front end. So, and that's because it's so normalized, it's very difficult to use for a user. So in my opinion, it should be only backend. So to store the data, to get your functionality right, your business logic, but then to show it at the front end, in my opinion, it's best to have it custom per customer, per project. You have your screens.
Yeah, so I think in many ways we're saying the same thing. If the back end becomes, this is how you've taken the use case, you've applied that data schema utilizing the ISA-95 structure, context, whatever word you want to use there, and then however the client, the person wants to visualize it, that's okay. Visualize it how you want, because all the data that you will want is already available and you know how to ask it the right questions.
Yeah. Right. Yeah.
So since we're talking about ISA-95, I thought it'd be a great segue. Now let's actually take a look at some of those parts in a very easy to understand, digestible, help unpack ISA-95 at a very high level. I believe there's a diagram that you have that demonstrates what some of those interactions are and what are some of the parts of that particular standard. So we get into the what are called the resource models, get into some of the information models. So let's get into that.
I will share this overview. This is what I sort of built myself based on what I read in the ISA-95, just to give like a very high level overview. It's also oversimplified, I would say. So a lot of connections are not there, but I think it's a good picture to start explaining how I see things.
Okay.
You have different parts. The part 2 is really describing the exchangement between level 3 and level 4. So that's like what I put up, like the upper half. The part 4, that's like the lower half. And what you see in the middle, sort of, it's the resource models, so the resource definition. It's described in part 2, but it's actually sort of shared definitions. So you have your definitions about material, you have your definitions about personal, about physical assets and role-based equipment. And that's like what we call resources, and that's shared. So it's linked to almost every object on the screen. It's linked to your planned orders, it's linked to your actual produced data, it's linked to your capabilities, it's linked to all the other stuff this is linked to and used to. Okay, so that's what we also call like master data, and it needs to be defined from which system will this be, which system is in the lead for what.
Okay, so in a typical manufacturing, as I describe it to people, I'm taking raw goods, I'm adding in energy, I'm adding in maybe additional materials, I'm adding in some labor. It looks like the resource models are doing something very similar, where I have materials that I'm working with, both incoming materials and produced materials. There are people that are involved on that, whether they're say line operators or technicians or supervisors. And I think the equipment is more like in the part 2 or the hierarchy structure, it's that enterprise site level, or enterprise site area line cell. And then there's also these asset definitions. So just can you describe a little bit between the difference between a role-based equipment and a physical asset?
Yeah, the role-based equipment, that was like in the early versions of the standard, it was only equipment. Equipment is really referring to which physical equipment you need in your process. So for example, could be a mixer. Then they added like the physical asset when they went more into maintenance, because a physical asset is really something that often it's like part of a role-based equipment, but it's very specific to the physical form of it. Okay. So if you take the example of a mixer, then the agitator could be, for example, a physical asset with a serial number, and it's part of that mixer 1. But the mixer 1, maybe you want to use in your order to plan on the mixer. In the end, you also produce something on that mixer. So that's where you relate to. When you then, for example, with maintenance, you replace your agitator, then you should check, okay, does this has the same capabilities or the same capacity? If that's all the same, then your equipment role-based equipment, could be then like the same. That's still the mixer, but it has a different agitator. So I think there you can say, okay, the equipment is really the link to the capabilities of something that will be linked to all the other models. The physical asset, that's really linked to the physical part of it. And yeah, that could be, for example, replaced.
Yeah, that's great. I understand it better. So thank you for explaining that, because that helps, me at least digest, the differences between the equipment and the asset. So now that we have the resources that are defined, you say those are all get used throughout the rest of the diagram here. So maybe we should start with that part 2 content of, just walk either left or right, or, however you think it makes the most sense to understand what's happening here.
Yeah, I think next step is to discuss the process segment. So process segment is telling something about about a process in your factory. So for example, you can take a mixing, or in a bakery, you can say, okay, bake a cake. That could be a process segment. Then if you go to operation definition and operation segment, that's also about, okay, how it should be performed. This is level 4, so it's the part 2. So you can have an operation definition with operation segment that's more specific, telling you how to bake a cake. It can also be how to bake a chocolate cake, for example. So then it's really specified on that. So that could then be an operation definition with operation segments coming, for example, from an ERP system or from a PLM system.
Yeah, the way I've understood process segments are they're like the smallest unit of work, and they're considered a template, and there'll be multiple process segments. You're using your cake mixing of there's the mixing of the cake, there's the baking of the cake, there's the packaging of the cake. And so those would each be process segments. But then the operations definition would be specific instances of we're going to make chocolate cake on line one, and Bob, our operator, is going to handle that. And so now that's a specific use of all those process segments. Is that a good way to understand that?
Yeah, that's right. It's also, and that's one of the things where ISA-95 is so flexible. You could say on a process segment, you always need this type of equipment, for example. And so on a mixing process segment, you could already say you need a type and equipment that can mix. You can also do that on the operation segment. So then it's decided at that level, you need this type of mixer. But you can even do it at your operation schedule. As your operation schedule is more about your planned order. That's what we call it often. It's also scheduled on time. So there you actually say, okay, this process segment, this operation segment, but now I want to produce this much of a quantity of this product and at a certain time. So then you're really making, or you're receiving an operation request saying, I want to have that type or that product of a cake. I want to have that baked or mixed at that moment, and this is the quantity. So that's how it's then linked all to each other. And that operation segment and also that segment requirement, that's then all linked to those resources.
Gotcha.
That's where it's coming together.
Okay, so the making of the chocolate cake on line one, we have it involved the operator that we're going to schedule that. So let's make that happen at 9 o'clock on Tuesday. Here's all the operations requests of this is what I'd like to have ready to go, Mr. Operator. And then in terms of the requirements, those segment requirements, these are the things you're going to need. It's like you're in baking, there's your sous chef of getting everything ready to go for you. And that's all mapped back to the material, the personnel, the role-based equipment, and the assets.
Yeah.
All right, so we're getting ready to go. We're baking a cake. Then what happens?
Yeah, so then you can say, okay, the work schedule and the work request and the job order, that's part 4, and that's more the level 3 to level 3 communication or exchange, or it can also go to level 2. That's more like a deeper level of detail. So you could say, okay, the operation request is saying I want this many quantity of this product, and I want to have it done before that date. Then at the work request, there you could go a level deeper. You could say, okay, I need to make 5 batches out of that. I need this specific equipment, this operator, so you can really specify it out in more detail. So what you often see in practice is that you get an operation schedule from an ERP system, for example, and then at MES level 3, there you're going to do detailed scheduling. So there you could say, okay, but now I'm going to split this out in multiple sub-orders or job orders, and each job order will be run on a specific piece of equipment or like a production line.
Gotcha. So the operations request would be, I need 100 chocolate cakes, but the actual work request would be, I need 20 chocolate cakes, but we're going to spread that over five batches, and those batches could get spread across whatever their overall schedule looks like. Is that right?
Yeah, and I could show a different picture to make that a bit more clear. If you look at this picture, it's coming from it's not that clear, maybe. It's coming from the standard. So here you have, for example, an operation schedule. The black box that says, okay, this is like a quantity of a certain product, and I want to have it done then, at that moment. And then here you see, okay, but that means for this production line, we need to do this. This production line, we need to do this. So per production line or per work center, this means you need to do some work. And that together, all those work centers will deliver your operation schedule in the end. So that's something where you see that deeper level of detail. So this is like what we see as a work request. And then each block inside, that could be then a job order, for example.
Gotcha.
Okay.
All right. So now we've made all this request. Here's everything we need to have happen. It looks like that right side in the blue and the purple, that's what happened, or did you want to spend some time there in that work directive capability model? Or
yeah, the work directive, that's more like the level 3 of the how to be performed. And so this can also give your exactly the steps, what needs to be done. It can also be linked to a workflow specification. So that's where you can exactly decide or model which steps should be taken after each other, and a whole route of steps that could be executed. And this can then be linked to a job order and also to that process segment in the middle.
So people will talk about the work instructions. Is that what that master directive workflow specification is talking about?
Not exactly, but it could be linked to it. Yeah.
Okay, perfect.
Thinking about the capabilities, to be honest, in practice, we're not using this as much at the moment, but this can tell you all about what's available in your factory. So
sure.
You could say, okay, what type of equipment is available, but also for how many hours a day, or for example, the capacity of a certain mixer. How big is that mixer? So that means how many liters can we mix per day? That kind of data we can cover in here. When you model that completely out, then you can really do things like detailed scheduling, or with contamination matrices. You can just schedule that on a deeper level in a better detail.
Okay.
Then going to the right, yeah, that's the response side. So that's really the actual work that is done. And of course, we want to report back what is done and how was that done. So starting at the level 3, so this is a direct response on the job order. You can have a job response. This will say, okay, this material was consumed, for example, this material was produced, this person was involved, this equipment was used. Can be equipment type, can be an equipment itself, the physical asset, same way. So everything comes there together, what was actually used and what was actually produced. Also, for example, about parameters. So at the job order level, you can have parameters as well. So you can say, okay, this combination we want to have produced in this way, but we also want to use these kind of parameters. Can be a parameter specific for an equipment, can be a general parameter. Then at the job response side, there we get also back the actual used parameters. So in the end, you can use the left side of this and the right side, you can use, okay, this was the target and this was actually produced. And you can compare, of course, if you were.
So this is what I asked to be produced. This is how we actually produced it based on, did we finish it on time? And what are some of those, those KPIs? So I would imagine that the right side is what people are mostly interested in, is because I want to have my big, pretty, a manufacturing dashboard that tells me how am I doing today. Is that right?
Yeah. So this is what you mostly see at your actual site and where people are most interested in. But if you want, for example, your KPIs, then you also need your targets. So then you also need the left side. Yeah.
Okay.
Going up to the level 4, yeah, that's more like, okay, again, that same level of detail. So the level 3 is just more detailed. And then you could say, okay, we aggregate, or we want to give a response back, for example, to ERP. Then you can say, okay, all these work responses or job responses come back into one big segment response or one big operations response, and that could be sent back to other level 4 systems.
Okay, so the job work response, work performance, that's around those 20 cakes we're doing in a batch at a time, but the segments response, operations performance, that's speaking to the overall 100 cakes that the level 4 system asked for operations to produce.
Yeah, that's also related to the operations schedule, and request is then also related to the operation response, for example. Yeah.
Sure. So, I mean, this to me provides the level of detail that I think we would want to get into today. I think there's probably a lot more, and we can certainly get deeper in that. So, like you mentioned parameters earlier. I think that's something we want to spend some time in a future podcast. So, if that's something that's of interest to the audience, then come back and we'll have that video here in the future. And Renee, we'll certainly get into the weeds on that. But since we've just provided a real high level overview here, the last piece I want to discuss is, that standard is 1,000 pages, and I think that can be ominous. But certainly, it's we're not the first people to actually learn how to use the standard. So if somebody were to set out to learn ISA-95 and more importantly apply ISA-95, what are some of the resources? Where are the places they can go to learn about it?
Yeah, they're all type of courses that I have seen, but yeah, that's mostly related to also where I live. So I don't know internationally seen.
Sure.
What's the best place to go. I think it's because it's a very abstract model. If you just start reading it, it's very difficult to understand it. And I think it's really good to have a factory in mind, or maybe a virtual factory, as we're using, for example, that bakery. That really makes it come alive. So there are also special courses to get S95 in practice. I think it would be good if, for example, also from a Rhize perspective, if we have some kind of demo that people can play with, they can really see these. We have an API that you can request all of those objects.
Sure.
That you can really make your own, model your own little factory, simple factory, and then you can start modeling more and more and more as you're learning. I think that would be the best.
Yeah, so it sounds like it's not a book or a standard. Is not something you would just say read. You digest it, you apply it. And really the best way to learn the standard, if I understand what you're saying, is you really need to have a hands-on application of let's call it a sandbox environment where you can actually get in and start working with some of these things and understand what they look like.
Yeah, and it's also good to mention, I think, that it's not fixed. Not much is fixed in the ISA-95 standard. It's all open for discussion and interpretation. So also, for us within Rhize, with the different ISA-95 specialists, we're still discussing daily or weekly about, okay, I would do it like this, I would do it like that. It's really, everybody has his own opinion. And of course, there's a standard with fixed rules, but because it's so flexible, so normalized, you can really, per customer, you also need to decide, okay, this will be the data model we're going to use.
Okay. Yeah, I think the last revision, at least of part 2, was 2018. I think there was a prior one to that in 2013. So, I guess the fair to say the standard changes with the time. So earlier I asked you about, does it still apply today? Well, yes, because the standard today was not the standard as it existed when it was first created. So that's great. Shameless plug here. You talk about the hands-on application. We are in the process of developing a training curriculum that will provide an overview from beginning to end of all parts of the standards. That'll be available to people, and then we'll also have a sandbox for people to work in. Of course, we're going to use our Rhize Manufacturing Data Hub as the back end for all of that, because the schema of that database applies and encapsulates the ISA-95 standard. So all of those equipments, all those resource definitions that we talked about, those are all going to be there. And as far as applying the standard and the operations requests and the job responses, all that context is going to be there as well. So anything more that you'd like to add before we sign off here, Renee?
No, I think we touched upon the very high level introduction, and would be good to have some more going into depth. So yeah, we'll see.
Yeah, absolutely. So just, stay tuned for more episodes of the podcast. As Renee and I mentioned, we're going to get into a little more depths of the ISA-95 standard. Of course, there's many topics as well. And then also just stay tuned for information around the training as well. We're excited to be launching that shortly. So thank you, everybody, for your time, and look forward to seeing you on our next podcast.